about just we'll have a brief overview about Unix in this session. And trust me, guys, it is the toughest task for me to do, because none of my past training session have been less than at least 2 days. But with limitations of time and all this stuff, I'll be trying to cover all the key concepts that I can, and we can have on later sessions or later videos based on other key concepts. So in this stage of when we are not much concerned about what we use, or means we are just provided with our pre-built system and all this stuff. Why do we need to know about Unix? Why do we know about Unix? It is because that before the day when Unix was there was Unix, machines use of machine were not such pertinent. Use of a calculator was even limited to either some heavily funded private organization or to all the government related agencies, because the embedded system those days, and it was very costly to build and to even to use all those stuff. It was a Herculean task. And once it starts to defunct, it cannot be upgraded. Like in today's date, we update all our software regularly. We update our Windows, or we update our Android. But those days, every machine was just compatible with the software that it was built with. I'm taking you back to the 1960s. Yeah, it was before the Unix was brought into action. So we can say that the revolution and Unix operating system, mind you, it predates any of the operating system that we use in today's date. So to say the revolution that Unix has brought, or what system has brought to the computing world and to the world and to the world entirely, we can say that the change is just massive. It cannot be just calculated. The introduction of all the system in this embedded systems or in the small devices enabled us, like I can explain. Suppose I consider the first hard disk in the 1940s, when the hard disk were into the market. It would hardly store some MBs of data, and it would size around more than a 900, more than a regular refrigerator that we use. So the uh, the efficiency, or we can say the facilities that were facilitated by the operating system, were immense. To give an example in a lighter note, I can say what operating system has done to the environment or to the world is like what Bollywood and cricket has done to all of the TV users. So let's start with Unix operating system, and we'll look into basics, look into operating system. For a one-liner, operating system is a system software. Means it's required by the system to run smoothly. It is like we have Android, or like we have MS Word or MS PowerPoint. It is not a system software. It's just application software. It's required by us to run our activities smoothly. But operating system, loader, linkers, these are all system-related software. Definitely required by the system for a smoother run. The Unix architecture, or the any of the operating system architecture, or the tasks of operating system also, we can say, it comes with a kernel, or the almost the bottom layer, which generally interacts with the hardware to provide us any of the input. Suppose I write a line of code to extract some file. It is work of the kernel to ensure that I have hardware for that, hardware free for that. And once I have the hardware free, means hardware here, I mean the register, the RAM, and we shouldn't go that way deep, but it is the work of kernel to ensure we have those facilities. And once those facilities are ensured, or once those availability are ensured, then again it fetches the file from the physical location. These are all the work of the kernel. You can say the bottom layer. The kernel is to the kernel, the user doesn't reaches out to the kernel directly. It is the work of the shell. About shell we'll learn later, but remember folks, the kernel is something which is generally not, which is actually not accessible to any of the user. Almost everything is protected. The processes that we do, the files that we do in Unix, it is just protected. And now we have various variants of Unix. Unix, we have Fedora, we have Ubuntu, HPOX, I guess, Sun for Sun, there is OS for IBM. But Red Hat Linux is the most used operating system. There are just various variants, but once you know any of the variant, it is very easy to use. And what the you and about this Linux kernel is the kernel on top of which Android is built. Linux is a open system software. When I say open system software, it means that not anyone can make changes, but the licensed user can make changes to the existing code or anything. That is what an open system software is, and it is the Linux kernel that has contributed in creation. That I think is the most used voice. It's the Android operating system. What is the shell? Just any of the command. When you search any of the command or anything, how the command gets executed, again, it is the work of the shell to ensure that it is a defined command. How the shell ensures it, we'll look into it we'll look into it in a nutshell. When I say commands, almost it is very clear now that in Unix everything we do with a command. There are almost around 3,000 commands or might be more in Unix. And each of the command comes with its own set of attributes, its own parameters. And remembering all those things is an immense task. So Unix in itself has we can say a key, or we can say the literature which comes in this man page. Means we can say man has the literature for all the predefined command in Unix. Just we type a man and the command name to get. Okay, let me just present it so that it's presentable. Okay, so for I generally use this system. I use Cygwin for executing my Linux commands. It is almost similar to Linux. Okay, so I can type my command. Suppose man, what man does. I can get the brief notes and everything about
the PPT is there on the screen.
Okay. So I should have share the Windows.
Now we can see. Thank you.
Yeah, thanks. So I use Cygwin for executing all of my Linux tasks, which is very close to Unix. So man pages, man. So just select see what this man does. It's a systems manual pager. Okay. Once we are in the Unix environment, it need not go anywhere else for executing, for looking about the literature of the command. We can just peep into the man page and get about the detailed analysis and all those things. Traversing this man page is also, we have to know how to traverse all this, and it is a part of VI editor, means text editor. Yeah, text Unix comes with such powerful features such as the text editor. It comes with powerful features like programming. When I say the shell script or the shell itself allows us to script, and trust me, folks, when it means 1970s, I'm talking about 70s and 80s, it has almost any of the advanced features that modern day programming languages has. Of course, it has its own limitations, but with scripting possibilities, with searching regular expression, with commands or utilities like sed, awk, and grep, perl, and Python is also by default installed in Unix in Linux since long back. So with all this combination, it just become limitless and boundless usage. We can use Unix for limitless and boundless usage. We can extract anything, almost anything in this type of environment. All the utilities need to be installed separately, and this is determined at the time when the system is installed. Now, looking to Unix or Linux, we just need to come out of our Windows type of mindset and look into the system. Like Windows has suppose now we are creating a now we are installing Windows 10. While installing Windows 10, we have to assign some particular directory, D directory, C directory, anything, C, D, E, F, and partition it likewise. Here also we have the partitionings, but that partitions are mounted somewhere, which is called, the file systems are mounted somewhere where it is called mount point. While creating the system based on the requirement, the administrator then partitions partitions it to various file systems. We can look to the status of the file system. We can look to the size of the directories individually. So two paradigms that support Unix is that one is file, other is process. And what we say is files have places and processes have life. I mean to say file resides somewhere and process have life. Means process gets born, it lives for certain time, means executes a task and it dies. On completion, the kernel just kills the process. Then rather it would be wrong to say kernel kills the process, but what kernel does is that it collects the exit status and on the execution, which is all managed by the kernel itself. So looking to the file system, we have a command ef to look into the file system. So yeah, well, it's my personal system, but in Linux it should be different. So here we have this C type where a sequence is installed D, E, F, D and F, but it's quite different in Red Hat kind of systems or Linux kind of environment. Everything based here is a command. Either it's a DL, DF command, be it DU command, and all these commands are case sensitive. So beware about the typos when we type the command. Okay. Here files also. When I say file, the files in general convention are some stream of readable text, but the binaries that we have, the command that we have, those are also file. Those are also installed binaries. Like I said, DF. So there must be a definition present of DF. That is why it is executing some task. Suppose I type now my name Shubhankar. It don't do anything. Shubhankar command not found. So definitely there is some source code for DF. As a result, DF is displaying an output. How to we can get the source code, we can get the type of command and many more things here. But user bin DF is hashed from user bin DF. When I see this file user bin DF, it must be when I see this file has certainly some attributes. What these LSFNL attributes are, it contains nine field and it has almost all the attributes to recognize a file. And this is the file user bin df. But when I cat is a command used to open the file user bin df. But when I open this file, I would just let me provide a filter. Okay. So there must be some unreadable character. There must be some binaries here. That is the reason. Means they cannot just provide it. They cannot just open it for everyone. Otherwise, their code is at stake. These are just binaries installed, and it is not readable to anyone. If it were readable to anyone, then again, various features of Unix, like when it comes to okay, just let me open my PPT. Those are long binaries there. Okay. So when it comes to Unix type of system, we say the sanctity, or when it comes to permission, when it comes to security of our files or of our documents, Unix stands sacrosanct there. There is just no question for security purpose or that purpose. And till date also, one other thing is that there are more at most handful, 5, 6 handful number of viruses that works that can do something on your system. But again, that is very rare. So, well, that is what means. That is what the robustness of Linux system is. And the idea in which this Linux system was developed is used as latest as in Hadoop. That we say in Hadoop we say data is permanent. The concept, this concept is also a core concept of Unix, which is called as link file or a hard link. Hard link where we ensure to maintain 3, 4, 5 copies of data. Of course, it will consume more space, but it is why it is preferred is that in this case when any file might get deleted due to any action, advertent or even inadvertent action, then we have to pay heavy penalty if the file is uh, file is of utmost importance. So hard-link concept is used so that 3, 4, 5 copies are stored of the same file, and any action on the other file would impact all the files, or any one of the file would impact all the files. But until and unless all the files are removed individually, the content remains there. Means the content we can visualize the contents and also go. Okay, let's look something about the shell, the basic commands and all these things. Who executes any of the basic commands or anything, means any basic command I provide, I might get an error. I provide any command to execute a file where I do not have permissions, I'll get an error. So here basically the task of shell becomes quintessential. What shell does, it just execute the commands for us. But to say that shell is just a command line interpreter would be a demeaning statement for shell. Shell comes with powerful operations of regular expressions, means of tackling with regular expressions. Various of Unix command has their own set of regular expressions also, but shells has its own set of regular expressions. It comes with powerful looping technologies for loop, while loop, until loop, a negated condition loop. It comes with powerful looping technologies to provide us get done of function recursion. And shell scripting, one of the most important features what an operating system can provide us. Of course, if you look about error handling and all those things, there are various ways where we can get the error. After even getting the error, we can run our program smoothly. But error handling and all this and a bit more advanced facilities like Python as NumPy, Pandas, Matplotlib, all this type of advanced facilities are not presented. Of course, we have HTML. We can write their HTML lines so that we get our output. We can get our output mailed in very fine CSV format, might be, or HTML line of code. We can write the HTML line of code so that we can get our table of output in very prominent way. Suppose I say at any point of time, if the total number of process exceeds 2000, I should get a warning in red color. We can key in those lines of code and we definitely would get that out. Okay, so that is what that is what we can say the features of shell is. Okay, about when I say about shell initialization, we can also talk a little bit of user login. So a user login by how a user login happens is initially the when we start the system, the kernel is loaded into the memory. What the kernel does is it looks into the init process. Then the init process starts the getty, which we call init process starts getty. Then the login process, it scans two files. Let me just put a hash here to comment. It scans two files. etc/password PSSWD file contains the attributes of a user, including the username. And etc/shadow, this file, etc/shadow file is not readable to anyone. Of course, the owner is root, but if we can, root is able to root. What etc/password contains, it contains the username. etc/shadow, it contains the password along with the username. But even if root can change the permission to read file, the file contains it in a binary encrypted format. So even anyone cannot change your password. Anyone cannot view your password. They can reset it on upon the user's request itself. Okay, but the password cannot be. Anyone else cannot view your password. Okay, and to change your password also you have a command. It is passwd. But it's not the time when you look into this basic command. So let's look into the shell. How a shell? Yeah, how a shell. Even the default shell is defined at the etc/passwd file. The default shell of the user is present here, and the user by default logs into this shell, which is stored in the environment variable echo $shell, or also we can get the process ID. As I said in Unix, everything that we run is a process. So the process has some attributes. Those attributes are stored in again a process table, which is stored in the memory which is only accessible to the kernel and no one else. Okay, about process. Even we can do echo shell or echo $$ to know the process ID. Shell is also a process. It should, if it is a process, it should definitely have a process ID. It is 937. To get the details of the process, also we have ps command, ps hyphen by bit process ID, ps hyphen fp, f for full listing, and the process ID 937. Generally not with, because we do not remember the process ID, but I just show you here so that I can explain something about this. Okay. When I do hyphen f, it means a full user ID, the user who is executing the process, the PID, and the parent process ID also. Every process has a parent process and the parent of all processes in it. And the start time of the process and the command means the command in the raw sense, what the command is executed. Like previously, I had said Unix comes with error handling also. It comes with standard output. Like I said, just see echo hello all. Oh, sorry, hello, it's typo. Ignore my typo. When I say hello all, I get it displayed in the terminal, which is the by default the setting of shell. But I can redirect this output to any of the file. Suppose it redirected out. Likewise, I can redirect input and redirect the error. Okay, ls-lrt to see this redirect, and I can view the contents of the file. Of course, so that's a cat command. Okay. Redirected out. We can likewise we can redirect the error also. That is what I said. We can, of course, we can handle the error. We can redirect the error. To redirect anything in Unix has a file descriptor. It is 0 for standard input, it is 1 for standard output, and it is 2 for standard error. Okay. About the process, we looked into something about the process. It's managed by the kernel. Process has a life, that it is born, or okay, when we start it lives as long as the running, or we can kill a process also deliberately. Suppose a process gets berserk, we can definitely deliberately kill the process. To kill the process, we have kill command. Okay. Each of the either of the processes, we can get the attributes of the process. We can either make any modifications that is required with the process, and to get the details of any user executing a process, there is another command. Apart from ps, there is another command, w. We have commands like top and SAR, system activity report, powerful command to get all the statistics of a process. When I come to the type of process, any of the process that we have executed here is a foreground process. Means all the processes are executed in foreground. We can also execute suppose I say sleep. Why I do a sleep 10 or sleep 20 here is that generally we do not have any task here which would run 20 seconds. That is why I do a sleep 20 here, so that it sleeps for 20 seconds. Means suppose I run a process in this terminal which takes an hour to complete. In that case, just waiting an hour or opening a new terminal would be waste of our time. What we can do, we can just redirect the process to background. There is a proper syntax for that. Sleep, sleep and ampersand would ampersand. Ampersand is ampersand. When we use ampersand, it by default it takes the job to the background. Means that is the design to take the job to the background. And once the job starts running in background, we get the job ID and the process ID. So let us search ps-fp104. User bin sleep. Okay. It would get completed shortly because it's something running around 20 minutes. And you see the PPID is 937, which means I have directly run in the shell itself. That is why the PPID is 937. Okay. The shell is itself a process that we had looked into previously. So this is how a process starts, fork, exec, and wait. We say is created with a fork system call. Means once there is a fork system call, we get the PID and of course the parent. A shadow of the process is run. It is then into exec when the process is running. Wait, the parent waits till the child is terminated. Suppose if the parent gets killed somehow and the child completes, then kernel by its design, the state of process that goes to orphan state. If the state is orphan, then kernel assigns init, the very first process that starts, and the init process then have the exit status, and then then the process gets completed. To accept user input in a shell script, we have a read command. Suppose I say read a and I read 55. A would contain the value 55. We have read command, various options with read also. We can test the evaluations of numeric, string, and also of files. Okay, we can test the files. We can embed any of this in a loop. For loop, while loop is common to almost all the operating programming language. Until loop, it's like a negation completed loop. Suppose until my value is less than 6, execute the command. And select loop is special to Unix kind of system which doesn't actually end. We have to break the loop to come out of the loop. There are some sample scripts attached here for better understanding with proper explanation. So we can look into this. And by this, I think I also have exceeded my time.
That's it.
That's it. That's it. And in times to
can
come,
we open any of the text, any of the script file?
Yeah, definitely. Let me do this function. Whether I'm not
just see the structure so that the audience get benefit of it, like how it's written. So someone who has not done in the past, he can see.
I was unable to open, so let me try it here. Okay, this is a shell script. Okay, cat and the script name. Deliberately, I have opened a larger script. Switch case. We have switch case in all the programming language. In Unix, we also have switch case, but it is case to start and ESSE to end it. Okay, like we use switch and case to start. What this script to do? Bin case. This should be the starting line of the shell script, which means it to determine the script to run in this shell. To look at all of the shells present, we can just do a cat /etc/shells. These are all the shells present in my system. Generally, in Linux type of system, we don't find this many. SH, BASH, and KSH are always found. And as I said, shell is also a file. It's a process, and it is the process, or it is the file which determines how other commands would get executed. Bin case, which we call the shebang line. By default, when we add a hash, you can see here it is added to comment, but when we add it with a bang and we provide the entire absolute path, this is called absolute path because it begins with root. It determines the shell in which the script would run. Almost we use SH, BSN and KSH, and all these three have the same functionality. Why this script? To determine whether I want it does 4 or 5 different works. Either we can find a palindrome script or a palindrome number or Armstrong number or leap year or even calculate the Fibonacci sequence. Let me just run it and we can see the structure. Functions are used here. Means all of those are user defined functions. See, the script starts executing. Echo -e enter a choice. I have to enter a choice. I can enter 1, 2, 3. I get display. Case choice in 1. Read STR. I have to enter this thing. Echo to, and once I read this STR, it would search for palindrome string, $string. It passes string as a parameter to this pal string function. For other, I'll just explain for this function. For others are clear. Pal string str is equal to $1 means the first parameter. Str is $1 which means the first parameter. Okay. I have used backquotes here. Backquotes is another form of providing input. Pipeline is another form of providing input, but to the command in the right. What pipeline does is it provides input. It provides the output of the left side command as input to the command in the right side. Okay. And well, rest is the logic of a palindrome string. Let's execute 1 or 2 instances of this. Yeah, it should be from here, right? It should be.
So to institute it,
yeah,
we give dot and forward slash and then
dot and forward slash
and then the file name.
Then the file name. Dot slash and file name. Let us run just one instance. VI is another text editor. Unix comes with various of text editor here. So my I go into insert mode.
Maybe we can open another. We can exit.
Okay. But we can also see here dots.
Maybe simple hello world program also, like how to.
Yeah, that should also.
Yeah. For
just escape, save the file, colon W. We can save in various modes, save the file in VI. Unix now the by default a file don't have execute permission, chmod. Provide execute permission. 7 I provide for user group and other 775 suppose. My function dot sh. Now dot slash you can get hello all. Okay. This dot slash is not compulsory, but it's a recommended practice. In which case we use or we might not use a dot slash is determined by our path variable. Echo $path. Path is an environment variable which contains all the paths where a program is actually searched. Suppose I do a ls, how does it gets executed? Path, the path. Shell searches this command ls in all of any of these paths. Suppose ls is present in any of these paths, then the commands get executed. That is how command gets executed by Unix. So this path variable is very. Suppose I do right? Now I do ls, ls won't get executed. Ls no such file or such directory because There in path there is nothing assigned. Only now internal commands should get executed. There are a handful of internal commands like cd and all such things. They should get executed. cd or document and so yeah, this is where there are very handful of internal commands. Almost all internal commands have a definition of itself in the shell itself. So yeah, I think I'm I'm done with this basics at least.
Thank you so much.
And yeah, thanks. Absolutely, thank you. My pleasure to present here.
Thank you for explaining the cell kernels and all the commands, and especially the shell scripts, how to write shell scripts, to execute shell scripts, how to give the permissions. So it was very detailed in nature, and it's going to be helpful for all the audience on YouTube as well as the one present here. So thank you, Suvankar. If anyone